So the last topic we're going to talk about here is using generative AI, in this case ChatGPT, as a problem-solving tool. What the heck does that mean? And I'm going to talk here about prompt engineering and why this is such a valuable way of teaching people how to do essentially critical thinking and computational thinking. And the way I like to phrase this is the democratization of computational thinking. It's probably fair to say that almost every field today can benefit from people who know how to think in a computational manner. What does that mean? It means being able to apply logic to evaluate and assess. It involves assessing things, like we were just talking about, with a checklist of different approaches, looking for patterns, automation, being able to generalize from a few small cases to see bigger structures, bigger patterns, and so on. Now, historically, when people wanted to apply computational thinking, they would come and say, teach me how to do that. So I would have people showing up from the biology department or the chemistry department or the divinity department or the department that looks at ancient texts, and they would say, we want to use computational thinking in our discipline. Can you help us? And what we would said for decades was, sure, we're going to teach you to use Ruby. We're going to teach you to use Python. We're going to teach you to use Java. We're going to teach you to use JavaScript, God help us, right? The worst of all possible solutions. And that was not what they wanted to do. And so a lot of people would go away very unsatisfied, or they'd try to take our courses, and they'd realize this wasn't getting them any closer to being able to think in a computational manner. Why is that? Well, as you all know, as programmers, as computer science students, there's a lot of things with programming that you have to master that distract you from the domain problem you're trying to solve. So you have to understand syntax. You have to understand memory management, especially if you program in languages like C++ and C, where one stray pointer can cause havoc. Concurrency controls, synchronization, parallel processing, buffer overflow. It just goes on and on and on. And a lot of those things, having taught those classes and taken those classes for decades, those are really distractions. They're just annoying. And they tangle you up in a web of accidental complexity. Well, what's a better way to do this? A better way to do this is to apply computational thinking via prompt engineering. And for those of you who don't know what this is, and I suspect everybody here knows what prompt engineering is, it's basically a structured way to interact with large language models using natural language as opposed to trying to use Java or C++ or Ada or whatever. And the great news about this is that it's not too hard. We'll see that in a second. And there's all kinds of interesting patterns that you can learn to be a more effective prompt engineer. So the way to be successful with this way of thinking, this way of computational thinking, is use the right versions of large language models. The more you pay, the better you get typically. Learn how to be a prompt engineer, learn how to use prompt patterns. We'll talk a bit about those in a second. And also understand other best practices like context is your friend. So the more context you give, the better the results are going to be. What's neat about this is it lowers the barrier to entry in many fields that require creativity and or technical skills. And so for a relatively small amount of investment, basically the price of 3 pumpkin spice lattes at Starbucks a month, which are about $20, depending on where you go and what the sales tax is, you can get access to tools that will be very, very good at helping you do what you do. So Claude, OpenAI, for about $20 a month, you can get access to the better versions of things. If you really want to go off the deep end, you can pay $200 a month and be a pro and get access to the really cool stuff. This is like the heroine of large language models. So deep research is my favorite example I'm using these days. Just outrageously cool. A lot of people here in this room, since you're computer scientists, this may be less important to you at one level, although being a good prompt engineer will help you out with everything else that you do besides your computer science stuff, and it'll also help you out there. But there's a lot of other people in other fields that are not programmers who will benefit wildly from this. And I think this is going to unleash an amazing amount of creativity with people who are very smart, like William & Mary students, but don't want to take the time to master the complexity of traditional or even modern programming language. So let's take a look at an example of how we did this. So in the same faculty meeting I was telling you about, the same computer science retreat where I had my poor colleague Jerry discover he needed to retire because ChatGPT was going to have people writing his solutions to his hardest programming assignments like nothing flat. We also were trying to come up with a way to evaluate what people's interests were. So before the faculty meeting, we we're told everybody some stuff, and we wanted to organize them into groups. And so I'm going to talk about how prompt engineering can be used to do problem solving without writing a lick of code. So what were we doing? Well, we asked everybody ahead of time, please give us a one-sentence description of what you are interested in talking about when you come to the faculty retreat. So there were 35 faculty members. We had 35 responses. So these were all the responses we got back. The next thing we did, so originally my co-chair, co-associate chair and I, she said, okay, let's take all those topics and we'll sit down together and we'll go through them and we'll see if we can figure out what some commonalities are and we'll allocate those people and we'll group them. I was like, are you freaking kidding me? So what we did is we said to ChatGPT, please read all those 35 descriptions and then group them together in ways that have cohesion. And it did, and it came back with, I think, basically 5 or 6 different groupings of topics. So there was academic and course programmatics, faculty and student development, graduate student stuff, research stuff, all kinds of things. There were basically 5 or 6 categories. So then what we did is we gave all the faculty a form to fill out which of these 5 or 6 topics they were most interested in being part of. And that was just a good old Google form, so they would indicate their preferences, and they would do it in the order that they wanted to do it. So they would say, I'm most interested in this, or I'm least interested in this. So now we've got a bunch of topics broken up into chunks, 5 or 6 chunks. We've got faculty who have expressed interest in certain topics. It's kind of like actually like trying to get your courses that you want when you're getting your courses here. And then she said, okay, this is great. Now we'll sit down by hand and try to match everybody up and see who goes in which groups. I'm like, no, Julie, we're not going to do that. We're going to use ChatGPT. So what we did is we used ChatGPT to map the faculty to the discussion topic groups. And so the prompt I gave basically said, here's input from 35 faculty members for their top 3 preferences, ordered from lowest to highest out of a total of 5 topics. Please generate output that allocates all 35 faculty members to all 5 topics, balancing them as evenly as possible, telling what that is, around 7 faculty per topic, taking their ordered preferences into account. Also, please give preference to faculty in the order they appear on the list below, because we wanted to reward people who'd taken the time to fill out the survey first. So, and then I gave it a little hint. I said, this is an entry in this thing. It's Doug Schmidt has these interests. And then I give a list of faculty in the format that they've done that. So what was really interesting about this is what we'll look at now. And now we're over into the wonderful world of recorded sessions in ChatGPT. So you can see this is the input I was just showing you. So each faculty member indicated their preference in the order there. And then ChatGPT went to work. And so it went and it allocated a bunch of people. And it said that the problem with this was it used a greedy algorithm, which is sort of the obvious way to do it. You just take each person's preference and you put them in the bin, and that's great as long as you don't overfit things. Well, the problem was that poor Jonathan Sprinkle ended up in a group he didn't have any interest in because it used a greedy algorithm. So I said, well, poor Jonathan didn't get where he wanted. Please use a different algorithm that respects everybody's preference and doesn't allocate faculty to topics they did not express interest in. And of course, I'm always very polite to ChatGPT, because when robots take over the world, I want them to remember I was nice. So remember that. So then it said, okay, I'm going to try using a bipartite graph matching algorithm. And then it came up with this thing called the Hungarian algorithm, because it was Kuhn and Munkres. Sounds like Hungarian names, which is a polynomial time algorithm that does optimal fit. And so it went and did this again. And lo and behold, even after doing that, Jonathan Sprinkle was still the guy causing trouble. So he was now unassigned altogether. So we weren't getting any better. Keep in mind, I haven't written a lick of code. I've just been talking to my chat buddy. So then I said, is it possible to generate a solution that assigns all faculty and guarantees each faculty member is assigned to one of their top 3 choices? And so then what it did is it ended up using randomization. So it came up with an algorithm that would randomly do the assignment, so it would avoid the problem of the order in which people had expressed their preferences. And it was a much more complicated algorithm. And it did some tweaks and adjustments. And now the funny part was it got stuck in an infinite loop at one point. It realized that. So it said, sorry, I've gone off the deep end. And then it tried yet a different approach. And so finally, it was able to come up with a way that good old Jonathan was allocated to a topic that he actually cared about. And it came up with a good assignment of everybody. And it gave everybody the right number. And back in the day, because this was a year and a half ago, it would also tell you or show you the Python code corresponding to each of the algorithms it came up with. It would still do that if I went back and prompted. I'm sure it would generate that. But I thought this was absolutely fascinating. And the reason why this is absolutely fascinating is I didn't write any code at all, but I problem solved. This is a great example of computational thinking via prompt engineering to come up with an algorithmic solution without having to write any code. And I'm sure nowadays that I could have done this faster. This is sort of the early days of me doing prompt engineering. I'm sure there's better ways to do this. I'm sure ChatGPT would do a better job of this. But it was really insightful for me to realize this is the way the rest of the world would come about this. And there were other people on the faculty, of course, who wanted to start by writing a Python script and doing this all by hand. And I guarantee you it would have taken them way longer to write that script and debug it than it took us to do a couple of iterations, prompting back and forth and getting ChatGPT to do all the busy work. So what I want you to take away from this is everybody is going to be a programmer. Everybody who uses ChatGPT or Claude or Gemini or DeepSeek or Grok or whatever it is they want to use, they're programming. It's just not programming in the traditional way that we think about programming from a computer science education, but you're telling the machine how to do your bidding. And the better you can express yourself, the better the results will be. So a couple things you might want to take a look at. These are a couple papers that we wrote. And this one in particular, this paper has been cited like 1,300 times in the last year. It's ridiculous how much it's got traction. And it talks about prompt patterns. I've been doing software patterns for decades, since the middle 1990s. It's 30 years of software patterns. It turns out that the same software patterns that we know and love for designing software, not the same patterns, the concept of patterns that we know and love from designing software can also be applied to doing prompt engineering. And people can use these patterns to do all kinds of cool stuff. Probably the most useful prompt pattern that everybody uses is the persona pattern, where you say, please pretend you are an AP history reviewer, and then analyze my document and give me feedback from that perspective. You can do some amazing things to get the better results from that. So that's basically the end of what I wanted to talk with you about today.